Hello everyone, this is Mr. Reese, and this is 5 questions. And what we're going to do is go over just simply 5 questions that concern three-dimensional figures, or solids. So let's get started. Let's start with determining the surface area of this cone. Now many teachers will require you to know the formula for this, which is the area of the top surface here, the circle, plus the area that wraps around. The formula for that is pi r squared plus pi times r times L. Pi r squared represents the top circle. Pi r L represents the area of the part that wraps around. In other words, the lateral surface area. The L refers to the length of this lateral edge here. So if you can find out its length, then we can input that into the formula. Writing out the formula is typically the first step that you'll want to use for any volume or area formula. So here we are. Now let's go ahead and plug in the values that we have. 6 represents the radius, so we're going to plug that in for r in both of these portions here. So we have 6 squared here and then just 6 here. L, though, we don't know. The lateral edge is not given here, so we're going to have to determine that. Did you notice this right triangle here? If you did, then you might recognize that we can use Pythagorean theorem here to figure out this third side. Recall that the Pythagorean theorem is a squared plus b squared is equal to c squared, where c represents the length of the hypotenuse, which is the longest side. We know this is the longest side because the biggest angle, 90 degrees, the right angle, is pointing right at it. So 6 and 8 are the two legs. We just plug that in. Solve for c, and if we do that, we wind up with 10. So now that we have that value, we can go ahead and plug that in right here. And now we can finish off this problem. The only remaining variable here is a, the area, so we'll just go ahead and do some arithmetic. 6 squared is 36. 6 times 10 is 60. And since these are like terms, we can just go ahead and add them together. So 96 pi is your solution, or you can just simply put in 3.14 in for pi and then give an approximation. Alright, let's do another. Let's say we were to determine the lateral surface area of this particular figure. You should first recognize that this is a prism. A prism is when the top and bottom surfaces are congruent and the lateral faces are rectangles. Now when you look at this figure, you might recognize that the top is really just an edge, this thing here. That doesn't necessarily mean that it's not a prism. It is in that it used to be standing upright. If it were standing upright, it would look like this, but this thing essentially has been teetered over like that. So that's what you're looking at here. So the bottom surface, instead of being this triangle here at the bottom, it is now this rectangle here. But it still doesn't matter. We still consider it a prism in that the top and bottom surfaces would have been triangles. Another way to determine that, other than the fact that we had an edge, is that we're looking at this front face here and it's not a rectangle, which means you're staring at the base. If you were to take this apart into a net, this is what it would look like. These are the 3 rectangles that unfold, and then this is the triangle. Now, how do we know there are 3 rectangles? That is, if you're having trouble looking at this figure, how can you tell? That's because the base is a triangle, which means it has 3 sides. If it's got 3 sides, that means there are 3 rectangles, one attached to each. Since the lateral surface area just involves the rectangles, what we're going to do is we're going to simply determine the area of all 3 rectangles and then add them together. So the area of the first rectangle, we'll call this one the first one. This will be the second, and this will be the third. Now, a word of note, all of these have the same height, which is 17. Remember, this thing used to be 17 units high. However, each one has a different base. Now, to determine the base, all you got to do is look at the triangle. The sides on the triangle base is going to tell you the lengths of each rectangle. That means if you were to assemble this together, these 2 sides would match together, so this would be 6. This, of course, is 10, and this would match with this. That would make this length 8. So 6 times 17 is the area of the first rectangle, 10 times 17 for the second, and 8 times 17 for the third. Okay, I'm going to leave it there for you to do the rest, but hopefully you get the idea on how we set this up. As far as finishing is concerned, multiply, 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 and then add all your answers. Okay, let's do a third here. You have a prism with a height of 6 centimeters, and it's got a volume of 54 cubic centimeters. What is the area of its base? Let's first start off with this formula, the volume being the area of the base times the height. Now, if this said pyramid, we would put 1/3 of the base times the height, but since it says prism, there's no 1/3. Now, the area of the base is what we want. We're going to plug in our other values that are given, meaning 54 and 6. And then all we do is solve for b. Divide both sides by 6, and we get 9, and that's it. Remember, we're just asked for the area of its base, so we don't have to do anything exotic here. Typically with problems like this, you would need to know the shape of the base and then plug in the appropriate formula for it. But in this case, you're asking for its area regardless of what shape it is, and that's what b represents. So that's really all there is to it. So let's do one where the base is actually important here. Let's say you have this cone and the volume is given along with its height. Determine the radius of the base. Let's first start off with our formula. Since there is a point at the top, we don't treat this like a prism, but rather like a pyramid. So we will use the pyramid formula for this cone. Now the base, you'll notice, is a circle. So what we're going to do here is we're going to plug in the formula for circle for big B. This is where it does matter, since the radius here is what we want to find, and it is a part of the whole base. In other words, we're not asked to find the area of the base, but rather a component of the base itself. So we're going to have to write in the formula for it. So for the b here, I wrote in pi r squared. Okay, now let's go ahead and plug in our given values here. The values that we're given are the volume and the height of the whole cone. And now we can go ahead and solve for the remaining variable. The remaining variable being r. There are essentially two ways to solve this. Let's first start by just simplifying this side. The 3 and the 30 reduce to give you 10. So that's 10 pi r squared on the right-hand side. We can just go ahead and divide out to get r squared only. So these would go away, as well as the 10s. Divide this and we get 289. Then we can square root both sides to finish off. And that's it. Now there is an alternate way to do this problem. So backtracking, what we can do is we can just simply multiply out the denominator of 3. That gives us 8670 on the left-hand side. On the right-hand side, the 3's reduce out. Then from here, we can just divide both sides by 30 pi. That gives us 289, and then square root both sides to finish off again. Either way works. Okay, let's do one last one here. Let's determine the percentage of unoccupied space in the box. Now the only measurement that we are given here is 16 for an edge, but believe it or not, that's enough. In order to determine the unoccupied space, the strategy here is to figure out the volume in this entire box. Then we're going to have to subtract the volume of this sphere. Now one of the things you should understand is that if from top to bottom here is 16, then from here all the way down to here is also 16. That means the radius of the sphere would be 8. So this is what we'll be looking to do. Find the volume of the box, find the volume of the sphere, then subtract, and that'll give us the amount of space. And then once we have that, then we can determine the percentage. The volume of this prism is the area of the base, which is 16 by 16, times the height, which is also 16. So that's what you're seeing here. For the sphere, it's just 4/3 pi r cubed. Pi is 3.14. The radius is 8. If you multiply these together, you get 4096. This second part will give you 2143.57. And if you're wondering how we did that, what we did was we took these values here and multiplied them together, which gives us 6430.72, and then divided by the 3 to give us this result. Okay, now let's go ahead and just subtract these. And that's our answer for the volume of unoccupied space in the box. So now let's take care of the percentage. To calculate the percentage, we're going to have to take that space and divide it by the total amount, which is the box. Now the box is 4096. We know that because we calculated it up here. Now whenever you do this division, you have to convert this to percentage by multiplying by 100. So we do that, and we should get somewhere in the neighborhood of 48%. So that is all there is to it.